In order to demonstrate the performance of DVDT's communication system at long line-of-sight distances, DVDT chose to leave headquarters for field testing at the beautiful Lake Somerville. Dakota and Vince took the TSAT a mile across the lake from David and Trent, who controlled the Earth station. The field testing was done to ensure that the TSAT can successfully transmit at 915 MHz with 27 dBm of output power through an antenna. The TSAT also needs to withstand high amounts of free space path loss simulated with added attenuation. The Earth station contains a small evaluation board connected to a laptop for communicating with the TSAT and handling data. David will describe the many tests performed in demonstrating long line-of-sight communications between the TSAT and the Earth station.
DVDT is transmitting across Lake Somerville. On the south end, Vince and Dakota are controlling the TSAT. On the north end, David and Trent are controlling the Earth station. The TSAT is transmitting at 27 dBm through a 9 dBi Yagi antenna, giving a total output of 36 dBm. The signal travels 1.67 kilometers across the lake, experiencing 96 dB of free space path loss. The Earth station receives the signal using a 9 dBi Yagi antenna. The calculated receive strength is negative 51 dBm.
Test 1. Transmit. Here's the results. Negative 47.9 dBm. And then, okay, I'm gonna tell you what's good and what's bad. That's the order I'm gonna tell you. So 59 good and 0 bad.
Next, DVDT added 10 dB of attenuation to the TSAT. The total path loss became 106 dB, which simulates a free space path loss at 5.28 kilometers. The calculated receive strength is negative 61 dBm.
All right, let's go.
Okay, 3, 2, 1, transmit. The average was a negative 57.3.
Okay.
That's
And
pretty.
How many good, how many bad?
I got
Bad.
52 good and I got 1 bad, but it was the very first one.
Next, DVDT added 20 dB of attenuation to the TSAT. The total path loss became 116 dB, which simulates a free space path loss at 16.71 kilometers. The calculated receive strength is negative 71 dBm.
All right, we can do this. Here we go. 3, 2, 1. I'm amazed at these results. Okay, all right. Average negative 68.2. 57 good, 0 bad.
Next, DVDT added 30 dB of attenuation to the TSAT. The total path loss became 126 dB, which simulates a free space path loss at 52.84 kilometers. The calculated receive strength is negative 81 dBm.
Turn on your
Okay,
high beam.
3, 2, 1. Oh my gosh, this is like on the dot. Okay, the results are in. Negative 78.2. 66 were good and only 1 was bad. And I'll tell you what happened. There was just a couple characters were added, but the actual packet was fine. Just some characters were added at the end.
Next, DVDT added 40 dB of attenuation to the Earth station. The total path loss became 136 dB, which simulates a free space path loss at 167.11 kilometers. The calculated receive strength is negative 91 dBm.
Okay, y'all ready? 3, 2, 1. I got negative 90.1. And then I got 67 good and 0 bad.
Next, DVDT added 10 dB of attenuation on the TSAT and 40 dB of attenuation on the Earth station. The total path loss became 146 dB, which simulates a free space path loss at 528.43 kilometers. The calculated received strength is negative 101 dBm.
Okay, here I go. 3, 2, 1. Wow. Done. Okay, y'all are gonna like this. You're gonna like this a lot. So, I won't keep y'all waiting anymore. The results are negative 99, 68 were good, and 0 were bad.
Next, DVDT added 20 dB of attenuation to the TSAT and 40 dB of attenuation on the Earth station. The total path loss became 156 dB, which simulates a free space path loss at 1,671.05 kilometers. The calculated received strength is negative 111 dBm.
Alright, so I'm clicking in 3, 2, 1. Packet sent.
I'm getting a lot of packets, and I'm not getting any errors. Wow, this is really good. So I got negative 109.9, and I got 89 packets that were good, and I have 0 packets bad.
That's
1,600 kilometers, let's go.
No way.
That's, yeah, 1,600 kilometers. Let's go bigger.
Can't believe it.
Go, add another one.
Let's go all the way.
Next, DVDT added 22 dB of attenuation on the TSAT and 40 dB of attenuation on the Earth station. The total path loss became 158 dB, which simulates a free space path loss at 2,103.73 kilometers. The calculated received strength is negative 113 dBm.
Alright, ready. Sending in 3, 2, 1. TSAT is woken.
Getting perfect results. I got negative 112.3, 85 good packets, and 1 bad packet. What happened was the W changed into a square.
Next, DVDT added 22 dB of attenuation on the TSAT and 42 dB of attenuation on the Earth station. The total path loss became 160 dB, which simulates a free space path loss at 2,648.44 kilometers. The calculated received strength is negative 115 dBm.
Alright, sending the packet, waking the TSAT up. It should be sent to you.
I'm getting stuff.
Aiming at the little light next to the bright light.
That's perfect.
These results are great. I mean the 2 dB added, and we're getting 2 dB less. So you're good now. So the average was negative 113.7, and I had 82 that were good and 19 that were bad.
Next, DVDT added 25 dB of attenuation on the TSAT and 40 dB of attenuation on the Earth station. The total path loss became 161 dB, which simulates a free space path loss at 2,971.6 kilometers. The calculated received strength is negative 116 dBm.
2, 1.
Okay,
Send my packet.
I'm getting them. Getting around 40% error rate, still going. So I got negative 114.7. I got 56 good packets and 45 bad packets.
Next, DVDT added 25 dB of attenuation on the TSAT and 41 dB of attenuation on the Earth station. The total path loss became 162 dB, which simulates a free space path loss at 3,334.19 kilometers. The calculated received strength is negative 117 dBm.
Ready?
I'm in receive.
Alright, waking the TSAT up.
I'm getting stuff. I got negative 115.8, 14 good packets, 86 bad packets.
Next, DVDT added 25 dB of attenuation on the TSAT and 42 dB of attenuation on the Earth station. The total path loss became 163 dB, which simulates a free space path loss at 3,741.02 kilometers. The calculated receive strength is negative 118 dBm.
Sending the packet.
I'm getting stuff. Okay, yeah, so we're getting pretty bad this time.
Okay.
I guess we're, getting on that edge now. So I got negative 116.4. We had 8 good packets, 86 bad packets.
Lastly, DVDT added 30 dB of attenuation on the TSAT and 40 dB of attenuation on the Earth station. The total path loss became 166 dB, which simulates a free space path loss at 5,284.33 kilometers. The calculated receive strength is negative 121 dBm.
No, we don't have it on the sheet, do we?
Yeah, we don't even have this going there.
This is-
Give me
This is why-
30 seconds.
This test is literally off the charts. So we should keep it off the record.
Wait, we'll try it.
Here's the problem. The calculated receive power is negative 121.
Oh.
So we might not pick it up, but we'll see.
Hold on. So 3, 2, 1. Packet has been sent.
Okay, I am getting stuff, but I'm getting 100% error rate. So I'm seeing like 117, 118. I see a 120. So it ranges. Oh, I saw a 122 in here. So I got 30 packets total. So I'm guessing there's a lot that were missed.
Yeah,
All 30 of them were errors. Pretty bad errors too. I mean, like the packet, for the most part, they all kept the same packet length, but there's just a lot of, jumble. In conclusion, these results validate that DVDT's communication system can successfully transmit at long line-of-sight distances, well over 400 kilometers. In fact, the packet error rate is still very small at around 2,000 kilometers or around negative 113 dBm sensitivity. So you're telling me that we just received packets over 3,200 miles away.
That's pretty neat.
That's pretty neat.